This is Geometry, Chapter 6, Section 2, Property of Parallelograms. Okay, so what is a parallelogram? So, definition of a parallelogram. Parallelogram is a quadrilateral, meaning a shape that has four sides, such that they're opposite sides. They have a pair of opposite sides that are parallel. A pair of opposite sides that are parallel. We're going to find out some other characteristics as well, but a parallelogram is a quadrilateral that has both pairs of opposite sides that are parallel. Alright, for the sake of purposes, I'll probably write parallelogram like this. I've been known to do that from time to time. Or I just might write a little symbol like that just to let you know. It's a quadrilateral that has both pairs of opposite sides that are parallel. So top and bottom, they're opposites. Left and right, they're opposites. They are parallel. Okay. So again, left and right. If this is left, then its opposite side is this guy. Top and bottom. Top is that, then the opposite of that guy in the bottom. These guys would be opposites, top, bottom, left, and right. And we also have something called, these are opposite sides. Opposite sides. All right. We also have, let's say this A, B, C, D. So we can say that AB and CD are opposite sides. Right? We also have opposite angles. So A, change the color. So angle A and angle C are opposite angles. Just like B and D is opposite angles, and BC and AD are opposite sides because they are directly across from each other. You can even think of them as the diagonals. The angles that form the diagonals, we can also say are the opposite angles if you want to see it that way. Okay. Which leads us to our first theorem of the day. Theorem 6.3, which is actually the definition of a quadrilateral. Now we just said it. A quadrilateral is a parallelogram. If a quadrilateral is a parallelogram, then its opposites, oh, no, this is different. Then its opposite sides are congruent. So we have our parallelogram. Not only are opposite sides parallel, not only that, we can also say that opposite sides are also congruent. Opposite sides are also congruent. So this is theorem 6.3. So So if a quadrilateral is a parallelogram, then opposite sides are congruent. In a parallelogram, opposite sides are parallel and opposite sides are congruent. They have the proof of it over here. I'm not going to spend too much time on this proof. You're not going to be really required to know this proof. There are going to be some proofs, though, in this section that I do want you guys to be aware of. We're told that it's a parallelogram, right? So then by definition, opposite sides are parallel. This is a transversal here. And this transversal is cutting across parallel lines BC and AD. So if you remember alternate interior angles, right? 3 and 2 are congruent, 1 and 4 are congruent. We can say that the diagonal AC is congruent to itself. Then we can say that both triangles are congruent because of angle side angle. So therefore any corresponding parts are congruent as well. So BC would be congruent to AD. AB would be congruent to CD. It's a 6-step proof, but I'm not going to ask you guys to be required to know that. But there are some proofs in there that I do want you guys to be familiar with. And we'll go over 1 or 2 of them today, but we'll go over some more the next time we meet, I think. Angles of a polygon that share a side are consecutive angles. All right. So if we draw these guys again, I'll be drawing a lot of parallelograms today. We call this ABCD. Angle A and angle B, they're consecutive angles. And they're consecutive angles because they share a common side. And this is the common side that they share. They share this guy. So angle B also shares a common side with that guy. So angle B and C are also consecutive angles. Angle C shares a common side also with angle D. They both share this side. So then angle C and angle D are also consecutive angles. And lastly, D shares another side with A. That's not what I wanted to do. How it keeps happening. Therefore, angle D and angle A are also consecutive angles. So every polygon or quadrilateral has 4 pairs of consecutive angles. Okay, and there's a rule associated with that. Since these guys are parallel, we can almost treat these like a transversal situation. This would be my transversal, right? This would be my parallel line, right? So here you have our A and our B. These guys are consecutive, right? But they're also consecutive interior because these guys are parallel. So if they're consecutive interior, from chapter 3, we know that these guys are supplementary. So consecutive angles in a quadrilateral are supplementary. That's theorem 6.4. If a quadrilateral is a parallelogram, then it's consecutive then its consecutive angles are supplementary. And remember, supplementary means that they add up to 180 degrees. Alright. So A and B are supplementary, B and C are supplementary, C and D are supplementary, A and D are supplementary, meaning they add up to 180. And that's because they are consecutive interior angles. Alright. Angle S is 86. What is angle R? So we have this hinge here for this quadrilateral. I'll rewrite it over here. Like so. This is Q, P, R, S, and we're told that S is 86. So what's angle R? So angle R plus angle S equals 180 because they're supplementary. So angle R plus 86 equals 180. So that means the angle R, the measure of angle R, is going to equal 94 degrees. I just subtracted 86 from both sides. So we talked about opposite angles as well. And in parallelograms, opposite angles have this special case too. And this is 6-5. A lot of theorems, but we're not having to prove them, so hallelujah. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So, in a parallelogram, A, B, C, and D, this guy and this guy are congruent, and this guy and this guy are congruent. Opposite angles are congruent in a parallelogram. Here's the proof. It's a flow proof. I'm good. You don't have to worry about it. But there's a proof down here that I do like. All right. And there's also a couple others in the book itself that I like as well. So we have a triangle. AKM. And then we have B, C, and D. Oh, we're told, let's see, that we have a parallelogram ABCD, and we're told that side AK is congruent to MK, so this guy and this guy are congruent. So prove it that these two guys here, A and C, M, D, say angle A and angle B, M, are congruent. So, couple of things. We sort of have to ask ourselves what we're dealing with, right? What am I looking at? Well, we're looking at a particular triangle right, that has these two guys that are the same. AK and KM are the same. They're congruent. So what does that mean? If you remember the isosceles triangle theorem, then I know that if the two sides are congruent, then the angles opposite are congruent. So I can say the angle A is congruent to angle M. I also know, because of theorem 6.4, nope, 6.5. Because of theorem 6.5, that opposite angles are congruent. So A is also congruent to C. A is congruent to M, A is congruent to C. Therefore, I can say that C is congruent to M. Transitive property of congruency. So first thing we start is our given. Whoops. Next thing I'm going to say is that angle A is congruent to angle M because of isosceles triangle theorem. Or base angles theorem. And I'm going to say that angle A is congruent to angle C because of theorem 6.5. Then I can say that angle A, C and D, that angle C is congruent to angle M, transitive property of congruency. Okay. Givens. Since this is isosceles triangle, then their angles opposite them are congruent. Isosceles triangle theorem. Parallelogram. If I have a parallelogram, then opposite angles are congruent, so A is congruent to C, theorem 6.5. And then using the transitive property of congruency, I can say that these two bad boys are congruent. Okay, I think this is the last theorem. Theorem 6.6 says that if I have a parallelogram and I have diagonals, the diagonals cut each other in half. So where they intersect, this guy and this guy will be congruent, this guy and this guy will be congruent. These two guys will be cut in half. So if a quadrilateral is a parallelogram, diagonals bisect each other. Okay. So if I have a parallelogram and I have a diagonal and I have another diagonal, these guys will intersect such that this guy and this guy will be the same, and this guy and this guy will be the same. These two guys will be cut in half. They bisect each other. Bisect means to cut in half. Alright, so let's do it. What do they want to know? They want to know the distances of PRSQ and first step. I know that these two guys are cut in half, so I know that for PR, in terms of an equation, I can say that 3y minus 7 equals 2x because they're cut in half. For QS, I can say that y equals x plus 1. So what I'm going to do is, anywhere I see a y, I'm going to substitute with x plus 1. That is the plan. So this is going to be 3 times x plus 1 minus 7 equals 2x. I'm going to use the distributive property. It is 3x plus 3 minus 7 equals 2x. Negative 7 plus 3 is negative 4. I'm going to subtract 3x from both sides. Negative 4 equals negative x. Therefore, x equals 4. Alright, so we have that x is equal to 4. Once we have that x is equal to 4, I can sub it into any one of these to find y. I'll use the QS. So y equals 4 plus 1, y equals 5. Yeah. Alright, so it doesn't matter which one I use. So if I plug in for P R, they should be the same. 3 times 5 minus 7, which is 15 minus 7, equals 2 times 4, which is 8. 15 minus 7 is 8. So 8 equals 8, so that works. But they want to know what the whole thing is. So this is going to be 8 plus 8 because it got cut in half. So PR equals 16. PR equals 16. Alright, so now we're going to do that for QS. So we already know what y is. So y equals 5, yay. So 5 equals 4 plus 1, so that works. So 5 equals 5. But they want QS, so QS is going to be 5 plus 5, which equals 10. So QS equals 10. Oh, last theorem. 6, 7. And what 6, 7 says is that if I have 3 or more parallel lines, cut off congruent segments of one transversal, then they cut off congruent segments of every transversal. Alright, what does that mean? I'm going to have you guys write that down. I'm not going to write that down because that's a lot of words. If 3 or more parallel lines cut off congruent segments of on one transversal, then they cut off congruent segments on every single transversal in the whole wide world. Okay, so what does that mean? So we have this transversal here. Actually, let's go A. So what they're essentially saying, this is what they're essentially saying. These guys, these parallel lines, have the same distance from each other. So that when I get a transversal, since they're the same distance from each other, then these guys would be equal. Because each parallel line has the same distance. From here to here is the same, from here to here is the same, and so on and so forth. So when I get a transversal, no matter what the transversal looks like, they're going to have the same distance from each other. So A would be C would be E. These guys would be the same from each other. What this theorem is saying is that since these parallel lines are the same distance from each other, no matter how I draw my lines, they're going to have that same distance as well. So these two guys are also the same. Anything I draw will be the same. B, DF. So if these two guys are the same, then these two guys are the same. always. And that's because the distance between these guys are also is the same. All right. Use the figure of 4. If that equals 6, then AD equals 15 with CD. Okay. Why are you red? I'll try my best to make these guys the same distance apart. A, B, C, D, A, F, J, H. Alright, so we're told that E, F, G, and H are all 6. These guys are parallel, 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 parallel. This is 6, this is 6, this is 6. Alright, they're all 6. They're all the same. Meaning this is congruent, this is congruent, this is congruent. Which means that all of these guys are the same. We're told that AD, this whole thing, is 15. So if this is 15, then I would just divide it by 3 because it's 3 equal segments, right? So 3x equals 15 divided by 3x equals 5. So this would be 5, this would be 5, this would be 5. They want to know what CD is from C to D. So from C to D, that would be 5. Because 5 plus 5 plus 5 is 15. They're equal, and I know that they're equal because these guys are equal. And that's that section. All right. I hope you have a great rest of your day.